Okay, class, today we're going to be doing is your parent a rational function? So first we want to say, why is it rational? If I look at f of x equals 1 over x, this is called a rational parent function because you have a ratio, which is a fraction. So written as a fraction with the number and the denominator, specifically the denominator has an x in it. Make sure you understand that the denominator has to have an x. So go ahead and copy this down. Now let's talk about why it is the parent. It's the parent because it's the simplest basic form that the function can come in. So that means it's broken down into its simplest form. So copy that down as well. So now what we want to do is we want to graph the function by completing the table and plotting the points. So I know if I have 1 over x and I plug in a negative 10, I'm going to get what? That's correct, a negative 0.1. Now if I plug in a negative 5, 1 divided by negative 5 is a negative 0.2. So I want you to keep proceeding and enter all those, and then you can compare them to mine. I'm going to give you a minute. If you need to pause, go ahead and pause. Okay, this is what you should have gotten. So now we're going to talk about what that looks like. If I were to graph that, what does it look like? Go ahead and graph each of those coordinates on your graph. So you're going to go over to x, go over to negative 10, and then go down 0.1 to graph that point. Okay, so you have 14 points that you should have plotted. What do you notice the graph looks like? You should have had a graph that resembles this. Now what this graph has is called a horizontal and a vertical asymptote. So we're going to talk about what an asymptote is. An asymptote is a line that the graph approaches as x and y values become extremely large or extremely small. So go ahead and write this definition down. And we want to talk about where the asymptotes are. So for the x-axis for this one, we have y at 0, and for the y-axis, we have x at 0. And I'm going to show you what that means on the graph. So this is telling me that this is approaching this 0 line. Try that again. This is approaching this 0 line, but it never touches it. And it's approaching this 0 line, but it never touches. So in this case, I have a horizontal and a vertical asymptote. Now, how does this affect the domain and the range? Looking at this equation, what do you know about the denominator? What can a denominator never be? Correct, that's 0. So in this case, the domain x can't be 0, and y can't be 0. So that's why it gives you that for an asymptote. So let's work a couple of problems. Okay, let's look at these 3 problems at the bottom. So it says these graphs show transformations of f of x, 1 divided by x. It wants us to draw the asymptotes and state the domain of each. So draw the asymptote and state the domain. So looking at this first one, I can tell that my asymptote, what it's approaching but not touching, is going to be right here, correct? So because that's my asymptote, how would I write my domain? What can my domain not be? Because it's approaching that and not touching it. My domain, which is my x, cannot be 2. Remember, that's my domain. The domain can't be 2. Now you go ahead and take a moment and work the next one. Well, let me go ahead and write your other asymptote. What's the other asymptote there? Don't forget that you have an asymptote there of 0 as well. What about the second one? What asymptotes do I have? What's my vertical? That's correct. My vertical asymptote would be right here. And what about my horizontal asymptote? It would be about right here. So what is my domain? What can X not be there? X cannot be a negative 1. That's my domain. X can be anything but a negative 1. Okay, now let's look at the third one. Go ahead and mark your vertical and your horizontal asymptote. So I'm going to have a vertical asymptote that's right here. And then I'm going to have a horizontal asymptote that's right here. So what can my domain not be? That's correct. My domain cannot be 3. So that is my domain. Any questions? Okay, we're going to stop there, and y'all are going to work the problems that are attached to this. And keep any questions you have for me. Enjoy your evening or enjoy the rest of your day.